We throw the word science around all the time, right? It's in everything, our cities, our phones, our medicine. But have you ever stopped to think about what it actually is? I mean, really, forget the lab codes and the crazy equations for a second. What's the real engine behind it all? Well, that's exactly what we're going to dive into.
Okay, so let's get right to it. When I say the word science, what's the first thing that pops into your head? Is it just, a giant encyclopedia of facts, a job title, or is it something bigger? Maybe a whole way of thinking about the world?
All right, so where do we even start with something that big? I think the best place is to try and pin down a solid modern definition. What are we actually talking about when we say science today?
Okay, look at this definition. Two words really jump out at me: systematic and testable. And this is absolutely key. It means science isn't just about what someone believes or their opinion. Nope, it's a structured process for figuring things out. It's a way to build knowledge that anyone, anywhere can check, verify, and then build on top of.
And if you look at where the word even comes from, this all makes perfect sense. Science comes from the Latin word scientia, which literally just means knowledge. So, right from its very core, the whole point was never just to collect a bunch of random facts. It's always been about that deep human need to understand.
Now, here's a little tidbit that might actually surprise you. The word scientist, it's super new. Seriously, it didn't even exist until 1834. Before that, the people doing this work, they were called natural philosophers. And that little change in name, it tells you everything. It shows this huge shift from science as just a way of thinking, a philosophy, to a full-blown professional career.
So, how did we get from those natural philosophers wondering about the world to the massive global scientific community we have today? Well, it's a pretty epic origin story, and it took a long time. Yeah, this definitely wasn't a single eureka moment. It was a slow burn, a gradual building of ideas over thousands of years, across so many different cultures. You can literally trace the path. It starts with, say, the essential math and astronomy from ancient civilizations like Egypt. Then the Greeks come along and start trying to explain things using nature, not gods. Fast forward to the Islamic Golden Age, where scholars started using controlled experiments, a huge leap. Each one of these steps was a building block for the next, all leading up to that explosion of discovery we call the scientific revolution. Okay, so what's the actual engine driving all of this? What's the toolkit that lets us turn basic curiosity into knowledge we can actually rely on? Well, at the heart of the whole thing is, of course, the scientific method. And I want to be clear, this is not some boring, rigid checklist. It's much more like a powerful framework for thinking, a way to ask questions that helps us get around our own biases. The whole point is to come up with ideas that aren't just, hey, that sounds good, but are actually testable, repeatable, and verifiable by other people. And this method really fuels two different but totally connected goals. You've got basic research on one hand. This is all about pure curiosity. Just how does the world work? Let's find out. Then you have applied research. This is where we take that fundamental knowledge and say, okay, how can we use this to solve a real problem? And what's so cool is that they feed each other in this constant, powerful loop of discovery and invention. Now, it's really easy to just lump science together as one big thing. But the truth is, it's more like a massive, sprawling family. You've got all these different disciplines, and while they're all related, each one has its own distinct focus, its own personality. And we can pretty neatly group this whole family into three main branches. You can think of each branch as a different lens for looking at the world. One looks at the physical universe, another looks at human society, and the third looks at the world of abstract ideas like logic. And this table really shows you the incredible range we're talking about. The natural sciences, that's your physics, your chemistry, your biology, they're all about the physical world. Then the social sciences take that same kind of rigorous approach and turn it on us, on humans, our economies, our minds, our societies. And then you have the formal sciences like math and logic. These are kind of like the operating system for all the other sciences. They provide the language and the tools that everything else runs on. Which brings us to a really, really important point. Science doesn't happen in some sterile, isolated lab. It's not in a vacuum. It's a deeply human thing. And that means it's tangled up with everything else, with society, with our values, and, yep, even with our politics. And really, the reason science works so well is because it's a team sport. It's a community effort. You have this global network of scientists who keep each other honest through things like peer review. They build knowledge together over generations. And that's structure. That's where the real power and reliability of science comes from. No one person has all the answers. The strength is in the group, in the collective process.
But that relationship with the rest of society, well, it can get complicated. Take a look at this data from the US in 2020. It shows how people's views on a scientific topic can sometimes line up with their political views. You see a pretty big difference here in the percentage of left-leaning versus right-leaning people who view climate change as a major threat. This is a classic example of what's called the politicization of science.
So the big takeaway here is that science isn't perfect. How could it be? It's done by humans, and it faces real challenges, both from the inside, like the replication crisis, which is a huge deal, and from the outside, like pseudoscience trying to look legit or political pressure. But, and this is the important part, the ultimate strength of science is that the method itself is designed to be self-correcting. Over time, the process is built to weed out the mistakes.
And that leaves us with one last big question to chew on. In today's world, where we're just drowning in information and misinformation, maybe the most important thing science gives us isn't just a list of facts to memorize. Maybe, just maybe, its greatest gift is a reliable, powerful method, a way to help us tell the difference between what's likely true and what we just wish was true.